Hi, so this is using data mining and modeling techniques to be able to detect and diagnose a disease through certain blood test results or demographic information. So in this case, I'm looking at healthy versus hepatitis, fibrosis, and cirrhosis patients. I actually found this problem through Kaggle competitions, but the data is blood tests from 615 people in Germany, and some of them are blood donors and some of them are sick patients. So there's information on a bunch of different blood tests, and then demographic information a little bit. So some problems that I had working with this data are that it's very uneven. So as you can see here, the blood donors make up the vast majority of the observations in this data, which is kind of typical when you're working with this problem of detecting a disease. So that is just one problem that you really do have to pay attention to with this kind of stuff. So another problem that I had was the large amount of missing values in this data, which it's not that large, but when we look at the values that are missing, a lot of them are from hepatitis, fibrosis, and cirrhosis patients. So these are going to be observations that I definitely don't want to get rid of because they're really necessary since there aren't a ton of them as we saw before. So instead, for the modeling, I just didn't use this ALP variable since it had so many missing values in the actual positive target class. And then I just filled in the rest of the missing values with the variable average since there really weren't a lot after getting rid of that variable. But also, this other blood test has a lot of missing values, but I wasn't as worried about that one because the majority of the missing values were accounted for by the healthy blood donors. So I didn't have as much of a problem just filling that in with the average. So when we look at the pair plot for all the blood tests, which are all numerical values, so they work really well for this. We can see in each of the scatter plots that there's kind of a clump of normal results, and then there's going to be like a few that are farther away from the cluster of the others. And just kind of by looking at it, you could see that these are gonna be the sick patients because there aren't a ton of blue dots that have a great distance from the rest of the clump. And the same for these. The next thing I wanted to do is look at the distribution for all the blood tests, just to see if they were all on the same scale, since I'm not really familiar with any of these tests. But I found that they do kind of have different ranges of values, so I thought it would be best to standardize them when the time came. As far as modeling goes, I wanted to first try a decision tree classifier, so I tried a bunch of different criterion and a bunch of different parameters for the minimum samples for a split. The results were kind of not good when I used the decision tree classifier with the best parameters, which were Genet and 20 for minimum sample split. There wasn't a great recall number for the sick patients, which is really what we're looking at when talking about diagnosing something or saying healthy versus unhealthy. We're really looking to detect the unhealthy patients would be the top priority. So then for the K nearest neighbors classifier, all the variables for the test results needed to be standardized then, and I just used those for this model, not any of the demographic information, just the blood tests. So what I found with the K nearest neighbors is that I actually got the best results when just using the one nearest neighbor. and that had the best recall for the sick patients. If I were looking at this problem again, I would probably change the data around a little bit to look at a more binary result, which would just be like healthy versus sick. I feel like I would get better results that way instead of trying to identify the sickness, just looking at healthy versus sick.